0.25 in a lower frequency range, so up to about 50 gigahertz. They were interested in knowing how that material behaves when we go up in frequency. So what you can see here are 3 measurements. Each line is a measurement. It's the same material, but measured one time with 1 millimeter thickness, one time with 2 millimeter thickness, one time with 3 millimeter thickness. And what you see when you increase the thickness is that you get more and more of those resonance peaks into your spectrum. And this is simply caused by the fact that you have standing waves inside your sample, depending on the frequency. And the thicker you make your sample, the greater number of standing waves you can generate as a function of frequency. So it's a nice example that shows the concept that's behind the measurement. And in this case, we see that the dielectric constant of the material is slightly higher than what it is designed for at 50 gigahertz, but on the other hand, we're measuring at very different frequencies. So I would say that both us and Premix were pretty happy with the result. Second example, this is the same material but at a higher level of doping to reach an epsilon of 4.5. And again, we see 3 different thickness measurements to illustrate the concept of the measurement, and a result that's pretty close to what is the design value for the material. So we make the fixtures at different frequency bands. We cover the entire millimeter wave and terahertz frequency range in accordance with what is available in terms of VNA measurement equipment. So from WR50 to WR1.0, 50 gigahertz to 1.1 terahertz. And as I explained previously, we're also working intensely on making different sample holders where users who have an existing material measurements kit can also buy additional sample holders when they want to move to liquid sample measurements, foam sample measurements, or powder sample measurements. In this case, the sample is confined into a sample holder with 2 glass C material windows on both sides of the sample. And there's a software add-on that's under preparation that will allow to de-embed the measurement from the sample and separate it from the contribution of the glassy windows to the S-parameter measurement. So if you want to learn more about those material measurements, we organize a workshop every year on new opportunities for industry in terahertz. The next edition will be beginning of February next year. It will be a special focus session on terahertz material measurements. And we have various speakers from Keysight Technologies, Virginia Diodes, Fraunhofer, Lakeshore Cryotronics, Schwarz, DuPont, ABB, AstraZeneca, ESA, Chalmers University in Sweden, TerraView, a group working on metamaterials at Boston College, and SPEAG, a company providing material measurement solutions for liquid samples up to 67 gigahertz. This is it for my presentation. If you have any questions or inquiries, you can either contact us directly, or for any commercial questions, contact Amtex that represents us in Japan. And that will be happy to help you for any inquiries. Thank you very much.
それではご質問のある方はそちらの前からよろしくお願いします。
Are there any questions? So for the moment, it's, let's say, empirical. We have a fixture that works at room temperature, and we can heat up the sample by putting the sample in an oven and then quickly putting it in the fixture, since the measurement only lasts for a second. Or likewise for cryogenic measurements, put the sample in liquid nitrogen and then quickly put it into the fixture. But this is, let's say, a quick and dirty approach, I would say. So we are now working on building a cryostat solution around the fixture, so that users who have an existing fixture can then purchase a cryostat extension in order to be then able to do measurements over a much larger frequency range. I would would say that the first aim is to be able to do measurements down to liquid nitrogen temperature and up in temperature, say, to about 100 degrees to cover most of the applications. So for those who didn't hear, the question is multi-layer samples. How can we measure samples with 2 or 3 different layers? So this is not something that is currently implemented in our software, but it is a software option that you have in the Keysight material measurement software. So if you know the number of layers that you have and the thickness of the different layers, then you can, from those S parameter measurements, separate between layers and resolve permittivity of those layers if it's possible. It's a data analysis option. It's a hardware measurement option. Any other questions? If not, thank you very much, and don't hesitate to come by the Antex booth for the live demo if you have more questions along the way. Thank you.